download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about the mole. So 1 mole of any substance is 6.02 times 10 to the power of 23 particles. And we call this number here Avogadro's constant. Now that's quite a large number to get your head around, and it really is a large number. But all you need to be aware about is that 1 mole of any substance is this number of particles. Okay, so let me explain. So for example, if we had 1 mole of oxygen, that 1 mole of oxygen would contain 6.02 times 10 to the 23 number of particles. Okay, so there will be this amount of oxygen particles in 1 mole of oxygen. Okay, and the same applies to anything. So if we then go on and start talking about compounds, so if we talked about 1 mole of carbon dioxide, 1 mole of carbon dioxide would contain this number here, 6.02 times 10 to the 23 number of particles. Okay, number of molecules. Okay, so that's a very large number to get your head around. But just be aware, if you can remember that number, that amount of particles make up 1 mole of a substance. Now this number is a rather large number, and some of you may be thinking, well, why did they make it such a large number? Okay, well actually this number is a very clever number. This number, so the mass of this number, 6.02 times 10 to the 23 particles of any substance, is exactly the same number of grams as the relative formula mass. Okay, now that sounds quite confusing. Okay, so let me explain what I mean there. Okay, so let's go to carbon, for example, as we looked at in the example in the last slide. Carbon has a mass number of 12. Okay, carbon has a mass number of 12. So what that means is 1 mole of carbon actually weighs 12 grams. Okay, 1 mole of carbon weighs 12 grams. And that is also its relative atomic mass. So that's why this number is a very clever number. Okay, so let's do oxygen. Oxygen has the relative mass of 16. That means that 1 mole of oxygen actually weighs 16 grams. So you can see here that the relative formula mass of a substance is exactly the same as a number of grams, the number of grams of 1 mole of the substance, and that's why the number's so clever, really. Okay, so it also works for compounds. So carbon dioxide, if you were to work out carbon dioxide, has a molecular mass, or a mass of 44. Okay, so that means that 1 mole of carbon dioxide is equal to, or weighs, you guessed it, 44 grams. Okay, so the relative mass of them is the same as 1 mole of that substance in grams. Okay, so you could literally keep going with that all day, really. Water, H2O, which has obviously a relative formula of 18. 1 mole of water equals 18 grams. And it literally works for everything, and that's why that number was chosen. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. So using that logic then, this equation fits in. So moles equals mass divided by the MR. Okay, and we need to be able to remember this formula because it does crop up quite a lot in chemistry. So moles equals mass in grams divided by the MR of the element or the compound. Okay, so let's go through a worked example then. So how many moles are in 10 grams of carbon dioxide? Okay, so let's always write down what we know. So we know the mass, we've got 10 grams here. So the mass here of our carbon dioxide is 10 grams. Okay, and it asks us to moles, so that also means we must know the MR. But it doesn't give us the MR in this question, but we know how to work out the MR, okay, because we've done it in previous videos. Now, if you haven't watched that, then please watch our previous video on relative formula mass, so you know how to work out the MR of different compounds. But here, all we do here, so we've got carbon, which we obviously find on the periodic table is 12. We've got one of them, and oxygen we've got two of, O2. So 16, and there's two lots of them, so times 2. Okay, and then all we have to do is add that together. And again, if you don't know what I'm doing, please watch the previous video on relative formula mass. So 16 times 2 obviously gets 32. Add that to 12, and we've got 44. Okay, so our relative formula mass of carbon dioxide is 44. So now we've got our mass, which is 10, and our MR, which is 44. So to work out the moles, we just have to do moles equals the mass, which is 10, divided by the MR, which is 44. Okay, and then pop that in the calculator, 10 divided by 44, and you should get 0.23 if you round it up. Okay, so that is your answer. So that means that there are 0.23 moles in 10 grams of carbon dioxide. Okay, so let's go through another example then. So how many moles are in 11 grams of this compound here? Okay, so we'll write the equation so we don't forget the equation. Moles equals mass in grams divided by MR. Okay, so we've got the mass in this equation is 11. And we need to work out our MR. Okay, so let's do that over here. So H3, well, H is 1 on the periodic table, so 3 of them is going to equal 3. Phosphorus is 31. If you look on the periodic table, it's the largest number. And O4, oxygen, is 16 times 4, which gives you 64. Okay, then we just have to add those together. So it's 64, add 31, add 3, gets you 98. So the MR of this compound here is 98. And then once we've done that, we can put it into our equation. So moles equals 11, which is the mass, over 98, which is the MR. Okay, we put that into our calculator, 11 divided by 98, and then you get moles is equal to 0.11. Okay, and that there would be your answer. So I want you to have a go at these questions here. So you've got question 1 and question 2, and there are 2 parts to each for you to have a go at. Okay, we will go through the answers to them after, so pause the video now. Okay, so let's go through the answers then. This question 1 is quite an interesting one. So first of all, how many atoms are there in 1 mole of atoms? Okay, well, we know that Avogadro's constant is the answer to this, and it's 6.02 times 10 to the power of 23. That's how many atoms there are in 1 mole of a substance. Okay, so that should have hopefully been the easier part. Now this next part. So if there are this many moles in 1 mole, or this many atoms in 1 mole of a substance, how many would there be in 2 moles? Okay, so what you'd have to do to work that out is to pop that. So that's the number for 1 mole. And if you want it in 2 moles, you just got to times it by 2. Okay, if you wanted it in 10 moles, you times it by 10. If you wanted it in 20 moles, you times it by 20. Okay, so that amount, the Avogadro's constant, times it by 2. And if you pop that into the calculator, what you should have got is 1.204 times 10 to the power of 24. Okay, so that should have been your answer for that one. Okay, all we did is we times our Avogadro's constant by 2. Okay, so number 2 then, how many moles are in the following 45 grams of chlorine molecule? Okay, so Cl has a mass of 35.5. Okay, so obviously there's 2 lots of those, so 35.5 times 2 should get you 71. Okay, so Cl2 equals 71. The mass is 45. Okay, then you want to put into the equation mass, which is 45 divided by mR, which is 71. So you do 45 divided by 71, and you should have got, okay, so 45 divided by 71, and you should have got 0.63 moles as your answer for that. So 0.63 moles. And for this second one here, let me just rub out my working over here to make it a bit clearer. Okay, so we got our mass, which is 40. And then we got our MR, which we need to work out. So N, H4, and Cl. Okay, so nitrogen has a mass of 14. H4, so H has 1. 4 lots of them is 4. And Cl is obviously 35.5. Okay, so then to work out our MR, what we need to do is we need to add these together. So 14, add 4, add 35.5, and you should have got 53.5 for our MR. And then we can do the mass, which is 40 divided by the MR, which is 33.5. On the calculator, 40 divided by 53.5. And you should have as your answer got 0.75 moles. Okay, and that should have been your answer for that one there. So we've now looked at what we mean by a mole. Okay, we've looked at Avogadro's constant, which is 6.02 times 10 to the 23. And then we've looked at how to calculate moles with the equation moles equals mass over mR. You can now move on to the quiz and onto the exam questions to really test your knowledge on this. And if you need any help or you didn't understand anything, then please get into contact with one of our tutors who will be happy to help.